Welcome back, everybody. So this is just going to be a review going over everything that could possibly be on the quiz, which is tomorrow, right? The quiz is tomorrow. Now, what is going to be on the quiz? Quiz is from sections 6.1 to 6.4. 6.1 and 6.2 being all of the exponent rules, including 6.2, which is the fraction exponent rules. Section 6.3 is all of just like the basics on exponential functions and what they look like and how they graph. And then section 6.4 was all those exponential growth and decay problems, as well as some compound interest as well. All right. So my first question is, what would we like to go over on the homework? Yes, Brianna. Which one? 15, sure. 15. It's on the back. On the back of the worksheet. Anybody didn't know there's a back of the worksheet? It's on the top right of the back of the worksheet. All right. Let's take a look here. Now, there's really two ways to do this problem. Okay, you could reduce all of the negative exponents and then subtract, or subtract then reduce the negative exponents. It's really up to you. I like doing subtracting and then reducing. Here's what I mean. Now, be careful with this. Be very, very careful. Am I going to subtract 12 and negative 9? No, I am not going to subtract those numbers. That's still division. That is still division. 12 divided by negative 9 is 4 over negative 3. Okay? I've got to reduce that fraction. 12 over negative 9 is 4 over negative 3. You've got to reduce that fraction. Now I start subtracting. Okay, look here. I've got, I'm going to use some highlighters here. Let's use those. A to the negative third divided by a to the negative second. Now, what am I going to do with these exponents?
Are you going to switch them?
I'm not going to switch them just quite yet.
Okay.
What does division tell me to? I could. But what does division tell me to do with the exponents? Subtraction. That's what I'm going to do here. A to the negative third minus 2. Negative 3 minus, actually that's negative 3 minus a negative 2, right? Be careful with that. That's negative 1. So a to the negative first on the top. And then b, 6 over 4. That's just b squared. B to the second. Now, can I leave that as an answer? No. Remember that a negative exponent or a zero exponent are not simplified answers. You must remove those. So like this negative exponent of 1 here, that has to go away. 4b squared over negative 3 times a. You could say negative 3 times a to the first. That would be fine. Why did I not move the negative 3 up to the top?
Because it's the number that was negative.
Because it's the number, not the negative. Or number that was negative, not the exponent that was negative. Okay, give me another one to go over. Tommy.
9.
Number 9. Okay, to reduce this one, first I'm going to do the distributive property, getting that fourth power in. So x to the 5th over times y to the 8th over x to the 4th, y to the 4th. And now I subtract exponents. Remember, whenever you got a parenthesis around with an exponent on it, you distribute it just like we did. Now we subtract exponents because I'd see division. X to the 5th over x to the 4th is x to the 1st. Y to the 8th over y to the 4th is a y to the 4th. If you did not have that first power there, that would be fine. If you just said x times y to the 4th, that's perfectly fine.
Can I still put it over 1?
Yeah, that's fine. What other questions would we like to go over? Gio?
19.
19? Yeah. Now, I got to be honest, I would not put one this difficult on the quiz tomorrow. This is kind of like an extension problem. See if, just try to challenge yourself a little bit. This would not be on the quiz tomorrow, but here's how we would do it. 3 times 5 gets us 15. X to the negative second times x to the first. Remember, I'm multiplying with my bases. I would add the exponents. Negative 2 plus 1 is negative 1. And then we have y to the third and y to the negative 8th. 3 plus negative 5, 3 plus negative 8 is negative 5. Now on the bottom, power to a power means we multiply. X to the negative 12th, and then we have that y to the negative 2nd sitting there. I get it. That's really confusing on top of what goes with what. Just make sure you pair each piece together. Numbers go with numbers, letters go with letters, x's go with x's, y's go with y's. And you're adding the exponent there because I'm multiplying with those like bases. Now, I have to subtract exponents here. 15 stays on top, and then we have x to that. Okay, negative 1 minus negative 12. Be careful with that. That's a negative 1 minus a negative 12, which gets me 11. X to the 11th power. And then negative 5 minus negative 2. Negative 5 minus negative 2 is negative 3rd. So this gets me 15 x to the 11th over y to the 3rd. That gives me my answer. Again, a lot of pieces in there, a lot of different parts. Yeah, question, Jeff?
How'd you get? That just doesn't add up.
What do you mean? What part is confusing you?
It's
The going the top to here?
you have like x11, but it's like x, like you got like
That came from here, right? If I'm dividing with bases, what do I do with the exponents? I subtract them. Negative 1 minus negative 12. That's where I get the x to the 11th.
Oh, I thought it would be
Minus. Minus a negative means plus. Negative 1 plus 11 plus 12 is 11. Yeah.
How'd you get to 15?
I took 3 times 5 on the top. Yeah. That's the part that's weird. Like we get so caught up in the exponent rules. I bet some of you said 8 because you might have said 3 plus 5. Remember, you're adding exponents. That's what you're adding. Yeah, put those together.
And then the bottom, the 2 or x to the second power, y to the 8th power. Yeah, mine's all over the place.
Yeah, I would say this because I know you like to move things when they're negative and positive, right? I would say reduce, then move. That's always going to be the easier route to take. Okay. All right. Let's get going on this worksheet that I gave you at the beginning of class today. So for those of you playing along at home, this is the practice quiz that's linked into the assignment. I will say this, if you want to know what's exactly going to be on the quiz tomorrow, this is the thing to study. What I just gave you at the beginning of class today, this practice quiz. Okay. I will say this, half the points of the quiz come from section 6.1 and 6.2. The other half the points come from section 6.3 and 6.4. Now, there are more questions on the quiz from sections 6.1 to 6.2. But that's just because I just have to give you a lot of different problems to assess whether you know all of the different exponent properties. Okay? The ones from section 6.3 and 6.4, those are more like the word problem ones, where I'm going to ask you to interpret and say, okay, is this growth? Is this decay? Write your function. Use your function to explain something else. But I'm going to go through a question, like each type of question that you may see on the quiz tomorrow. Now, some of them, like, for example, question 1 and 2, very similar. Question 3 and 4, very similar. Questions 5 and 6, very similar. Okay? There are some repeats on here. All right, let's get to it. Number 1 here, negative 6 to the negative 2nd power. Can anybody just tell me what the answer should be? What should the answer be? Nathan?
Negative 1/6 raised to the second power.
I'm going to say,
1 over negative 3.
and then you have to actually take 6 to the second power,
Okay.
which is 1 over 36. Okay? That's what I wanted to get to.
I got 36 over 1. Is that acceptable?
No, because that's not the same
Why
thing.
is it on negative?
Hold on a second. That's not the same thing. you have to move it into this negative exponent tells me I have to move it into the denominator. So the 36 can no longer be in the numerator. It has to be in the denominator. Okay. Why is it not negative? Because there's parentheses around it. If you take negative 6 squared, that's a positive 36. No more negative. Okay. Same thing with number 2. This would move it down into the denominator, so 1 over 2 to the positive third power, which is 8. So 1/8. This one's really lagging behind, isn't it?
Yeah.
I should restart it. All right. 4/8 is a 0 over t to the negative 5th. Somebody tell me, what happens with the a to the 0? Poof. It vanishes into thin air because anything to the 0 power is just 1, so it basically just cancels out. Don't make it an a. The whole thing goes away. The 4 remains on the top. And then what happens with my t to the negative 5th? Yeah, it was negative on the bottom, not happy on the bottom, moves to the top, t to the positive 5th. Now, you could put this over 1. Right? That is completely fine. That's the question Noah keeps asking. Can I put that over 1? That's completely fine if you want to do that. You don't have to, though. Okay? This is just another acceptable answer there, 4t to the 5th. Now, if everything moved to the bottom, you would have to put a 1 on the top. Okay? But if everything moves to the top, you don't need a 1 on the bottom. Now, taking a look here, number 4. Is G happy on top? No, move it to the bottom. Does 3 get moved to the bottom with it? No, the 3 is not raised to the negative exponent, just the G. And notice that I am just leaving that y to the 0, letting it go. I'm not going to write it anymore. Okay, let's keep it moving. Number 5 here. Okay, 5 and 6, very similar. The x, not happy, move it to the bottom. The 3 is happy, don't move the 3. The y goes away, the k goes to the top. There's my answer. Same thing with 6. The 7, happy where it is. The b, happy where it is. The a, move it down. The c, move it up. Somebody asked me last period, does order matter there with the b and the c? Nope. You could say 7, c to the 5th, b to the 4th. You could say c to the 5th, 7, b to the 4th. It doesn't matter. It's all multiplication, so order does not matter. Number 7 here. Okay, this is just asking me to evaluate. Negative 7 to the 3rd power is a negative 343. Is that right? Yep. Negative 343. And then you would say, okay, times negative 2 to the 0 power. Well, negative 2 to the 0 power is just 1. So we just don't write it anymore. It would be negative 343 times 1. Number 8. Multiplying with like bases means I add the exponents together. A to the 3rd times a to the 8th is a to the 11th. I cannot do anything combining it with that c to the 5th. Please don't make it like ac to the 16th. No, that doesn't work like that. Don't have like bases, you can't combine. Okay, let's keep it going. I want to try to get through this whole worksheet today. All right, what is it telling me to do with these exponents on 9 at the front here? Gio?
Multiply.
Good, so that would be x to the negative 20th times x to the 8th. Now what do I do with the negative 20 and the 8? Add.
Well, same thing.
Kind of, yeah. I'm going to have negative 20 plus 8 is negative 12. Now, could I put that on my answer blank? No. The negative 12 exponent is not simplified. You must move it down into the denominator. So this becomes 1 over x to the 12th. Number 10. Yeah, there will be questions quite simple, just like show me the property. Show me the property. And may I add that we should all be writing these down with me as I go. If you're just sitting there watching, good luck tomorrow. B to the 10th over b to the 3rd is b to the 7th. Remember subtraction. Number 11. Now be careful here. I bet a lot of you would tell me that I would do the distributive property in here. But be careful. Is that going to be a 9 in the front? No, that is not 3 times 3. That is 3 to the third power, which is 27. Now, I do multiply the power of 5 with the power of 3. You multiply powers when you take power raised to another power. When I take a number raised to a power, you just got to take that number raised to the power. 3 to the third, which is 27. Number 12 over on the right side. I've got to distribute this. X to the 6th, y to the 9th over x to the 3rd, y to the 3rd. Okay. Now I subtract exponents. Now I say, okay, x to the 6th over x to the 3rd. 6 minus 3 is 3. 9 minus 3 is 6. Questions about that one? Okay. Our last set of exponent problems here. Now, there's a couple ways to do number 13. I could reduce and then bring in the power of bring in the power of 2. Or what I would like to do is bring in the power of 2, then reduce. Here's what I mean by that. When I bring in that 2 to the 5, what does that become? 5 to the, not 10, 5 to the second. 25. Be careful, whenever it's just a number, you got to raise it to the power, not just multiply. This should be a 10th power. This should be a 4th power. This should be an 8th power. And now, to finish it off, all I need to do is just reduce that. Subtract my exponents. 25, a to the 6th, over c to the 8th. What does a negative exponent do on a fraction? Flips it. It flips the fraction. So this 4 over b becomes b over 4 raised to the positive power now. Now I distribute it in. B to the 3rd over 4 to the 3rd, which I should have just wrote that 64. B to the 3rd over 64. Question? Good. Now, those are all the exponent properties that are on my page. Don't forget that you are going to be responsible for knowing how to do this. I did go through this in the video on Friday, but again, not many people watch the video with care. Remember that if there's a fraction exponent, the numerator of the fraction is the power, the denominator of the fraction is the root. So if I ask you to go from fraction exponent to radical, well, that would be like saying the nth root of a to the m being the power, n being the root, or you could take the root first, the nth root of a, all raised to the m power. Like, for example, I'm going to be asking you to do this. Reduce x to the 8/3 power. That means the third root of x raised to the 8th power. That's a completely acceptable answer. Or x to the 8th power, and then take the third root of that. That's a completely acceptable answer. The other thing I could do is ask you to flip that around. So write it as a rational exponent, basically. So if I had like the 4th root of c to the 7th, what would that be? No?
C and then 4 over 7, or 7 over 4.
7 over 4, power over root. Yeah.
Is this the formula?
No. I'm just adding this in.
But like here on the paper, like is this?
Oh, let's go through that. Let's talk about exponential growth and exponential decay. Okay, that was the end of section 6.1 and 6.2. This is where we pick up with 6.3 and 6.4. Now, remember that exponential growth and exponential decay are very, very, very similar formulas. And I will not be providing you with either of these on the quiz tomorrow. You have to know these. Remember, it's little a times 1. Then we've got our rate in there raised to the x power. Oh, that's an x. X power. What is the only difference between growth and decay, Henry?
Plus or minus.
The plus and the minus. The plus is for my growth. The minus is for my decay. You have to know what those mean, though. Little a is your original amount, my starting value on the outside. R is your rate. What do I have to do to that rate? What do I have to do with the rate?
Decimal.
Make it a decimal. And then we have to remember the plus and the minus. And the x is always the time.
On like the online worksheet, there's like a question where the rate was like it was 1.10, but instead you changed it to like 0.1 because it's like a decay or something like that. I'll try and show it to you.
Okay. Now, the only formula that I will be giving you tomorrow, I'm going to write it on the board as the compound interest formula. Now, I'm not going to tell you what each piece means. You have to know this. Okay, that is the compound interest formula. Remember, it's very similar to the exponential growth formula with one key exception, this n in there. Remember, n stands for the amount of times the bank is going to compound per year. Like, for example, if I'm going to compound semi-annually, I'm going to put n as 2 because it's going to happen twice per year. If I'm going to compound quarterly, n turns into 4. If I'm going to compound monthly, n turns into 12. If I would compound daily, that would be 365. Okay? P is your original amount, your principal in this case. R is your rate as a decimal. T is obviously time. All right, let's take a look here. How do I tell whether something is exponential?
Exponential would be doubling itself, or vice versa.
But it doesn't have to just be doubling.
Oh yeah, because it could be to the third or fourth power too.
Right. So what would that be? What would that look like in a table?
If something squared.
Be careful. I'm looking for multiplication within my y values.
Okay.
If I'm consistently multiplying in my y values, like for example, you might be tempted to say number 1 is exponential. Because you might say, oh, look, times 3. Do all of those fit that times 3 pattern? No. So this is not exponential. Okay. Is 19 exponential?
Yep.
Yes. What's my pattern?
Times 2.
Times 2. Now, so 19 is exponential. Would you consider that exponential growth or exponential decay?
Growth.
Exponential growth because it's going up, right? Now, what would 18 be? It's not exponential, but look at the pattern in the y values.
Exponential.
It's not
Or
exponential.
linear. Sorry.
Linear.
I was looking at the board.
It's linear. What's the pattern?
Plus 18.
Plus 18. So while it's not exponential, and it didn't ask me for this, I could say that this is linear. Okay. Because I see a constant addition. Flip it over onto the back, please. Now, let's take a look at number 20. 6 times 4 to the x is a modeling insect growth population, or insect population growth. Now, this didn't ask it, but let's kind of break down the formula. What is the 6 representing here? What is the 6 representing? Where I start, the initial insect population. So maybe 6 insects. What is the 4 telling me?
How many times it goes up per week?
Yeah, it's quadrupling, right? That's what we're really saying, right? Multiplying by 4 each time. It's almost like it's a 300% increase. Okay, now, but that didn't really ask me for that. All I really want to do is just say, okay, after 7 weeks. Now, if it's quadrupling each time, don't be afraid of big numbers here. 6 times 4 to the 7th, 98,304. Do not be afraid of big numbers. Insects. Yep. Yeah. Number 21 here. Okay, all I'm asking you to do is just graph. So we got negative 4 times 0.5 raised to the negative second. Looks like it's negative 16. Same thing raised to the negative first power. Looks like it's negative 8. Raised to the 0 power. It's negative 4. Now notice the pattern, it's dividing by 2 each time, right? How do I know that this is exponential decay then? Brianna? Yes, that it's going down, right? But based on the equation, how do I tell that it's decay? Okay, yeah, I see that pattern as well. But like within the equation, what about the equation? Nick?
The thing is less than 1.
Yeah, the base of the exponent is less than 1, the 0.5, right? But we're right. Everything else you said was completely correct. That is dividing, it is going down, has that pattern. I'm going to do this for you on your quiz tomorrow. I'm going to be giving you a blank graph, and you kind of have to fill it in because I don't want to lead you in any direction on like, okay, it's going to be downward or upward or whatever. Okay, negative 2 comma negative 16. I'm going by twos here. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 4, 2, 1. Now, how picky am I going to be on your graphs? Well, I'm going to be looking for a couple of things. First thing, I'm going to make sure you don't put a straight line. I'm going to be looking for a curve. Second thing, should you cross the x-axis?
Yep.
No.
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 That's confident.
I know. No, you should not be crossing the x-axis. The x-axis should not be crossed. Okay? Question.
If you're graphing, like, maybe I'm wrong. If you're graphing like those points as negative 2, negative 16, it would be like the point would be like way down there. I don't know why it's like up there at negative.
Here's negative 2 comma negative 16. I'm going by twos. Here's negative 1 comma negative 8.
Wouldn't that be like the wrong quadrant though? Like that's like
Negative, negative. Negative, negative.
Hey, Gio.
No, it's in the right one. It's in the correct one.
Yeah. How you know what a quadrant is?
Trust me, it's good.
all right. I see.
I'm gonna try to keep going here. The bell's gonna ring on me. I will just keep teaching this even with nobody else in the room. So if you want to check this online tonight, I would strongly encourage you to look at the rest of them tonight.
Doesn't that get weird?
Shh, just let me keep going, please. The original value of a painting is 11,000 and is increasing by 14% per year. That tells me right there that it's exponential growth. So I know it's y is equal to a times 1 plus r to the x. All right, so my a value in this case is 11,000. My r is 0.14 raised to the x power. So my function, remember that the function should have a y and an x. Y is equal to 11,000 times 1.14 raised to the x power. Don't give me a plus sign in there. And then it says, what's the value going to be in 25 years? Well, I'm just going to take that 11,000 times 1.14 raised to the 25. 11,000 times 1.14 to the 25th power. That's a lot of money. 291,000. 81. So long, everybody. $291,081 and 74 cents. That's a big jump. That's good money right there. 11,000 to 290,000.
Yeah.
I mean, that's what I got in my bank account. I don't know about you guys, right? Okay. I don't know. I love it. I do it because I like it, not because I need the money. just making sure that was recorded. All right. At a movie premiere, 1750 people attended. The attendance decreases. So this decrease tells me it's decay. So it's a times 1 minus r to the x. So y is equal to 1750, 1 minus 0.15 raised to the x power. Make sure you put that percent as a decimal. So this is 1750 times 0.85. 1 minus 0.15 is 0.85. 1750 times 0.85 to the x power. And it asks me in 9 days. 1750.
How'd you get that step?
You're funny.
Bye, have a nice day, Mr. Hopper.
You too.
Thank you.
I'm still recording this. Hi.
I totally forgot.
That's okay.
First period, I was like, oh my god.
That's okay. I'm recording. I'm finishing teaching this
okay.
lesson.
No, go ahead. Take it.
That's okay. 405.33. 405.33 people. And then here is number 22. Apparently I misnumbered. Find the balance of a $3,900 investment. So remember, this is compound interest. So P times 1 plus R over N to the NT. So P is 3,900. R is 0.029. N, compounded quarterly, N is 4, and T is 16. Okay, so 3,900 times 1 plus 0.029 over 4. So the 4 times 16. All right, now I'm just going to go through 0.029 divided by 4. That's 0.00725. I'm going to add 1 to that. So that's 3,900 times 1.00725, all raised to the 64th power. All right, 3,900 times 1.00725 raised to the 64th power. So that gives us $6,192.28. 61.92 and 28 cents. Okay, now for anybody watching till the end of this video, here's your name on your paper on your quiz tomorrow. Here's your quiz. If you write a big smiley face next to your name, I'll give you a 1 bonus point. For anybody watching this video till the very end, kudos to you. Bonus point to you. Have a great day. So long, farewell. Auf Wiedersehen.